right, we are going to get started. Good morning, or good afternoon, or good evening, depending on where you are. My name is Graham Hargraves, and welcome to the CAD-CAM Consulting Services and Vericut webinar. Okay, so today we're going to talk about Vericut, Vericut Force, Optimizer, and how Vericut works with Mastercam. So we're going to do a little intro and overview, who we are, who Vericut is. Then we're going to jump in with Jake to talk about Vericut as a company and Optimizer. Then Frank will take the reins and start talking about Vericut and how it interacts directly with Mastercam. And then we'll do a little closer. So as mentioned, we're going to talk about all those products. The thing that's very special about this is it's two proven industry heavyweights working together to help you achieve success in whatever you do in manufacturing. And we are offering these products locally through CAD-CAM Consulting Services. So a little introduction, Frank Gonzalez, he works in applications for us. Myself, I am the strategic business manager, and we have Jake King, technical support engineer with CGTech Vericut. Just some housekeeping before we get started. This is scheduled to be a 1-hour webinar. We'll try to keep it to that. There is a Q&A option. We're gonna ask that you type those into the chat. We'll do our best to address them all before our time is up, and of course, keep them appropriate. So then we'll do a little follow-up. You know, if you're interested in what you saw, we'll have our contact info again at the end and where you can find everybody. We are recording this, so later on this week, we'll put it up on YouTube and we'll send everyone a follow-up email, you know, a little thank you and where you can find that recording. So we also ask that you remain muted and turn your camera off. As I'm seeing people, I'm kind of muting you because that option didn't seem to take when I booked this. So who is CCCS? We've been around since 1993 in Southern California and surrounding areas. We're providing additive, subtractive, and inspection software and hardware solutions for manufacturing. On the additive side, we have desktop metal 3D printers and robos. On the subtractive side, we have Cam Assist, which works in Mastercam. Also Mastercam. Mastercam probing, which if you see the little icon over here on the top right, that used to be Simco, but it was just acquired by Mastercam recently. We also sell Mold Plus and, of course, Vericut. Then on the inspection side, we have Verisurf. So we're local, we're experienced, and we're dedicated staff. Many of our staffers have been around for over 25 years at this company, so quite the longevity and industry knowledge. We're located in Anaheim, Newbury Park, and San Diego. And out of all three of those locations, we offer on-site training, and we're local for support. So if we need to come out to you, we can kind of hop in the car and get out there as quickly as possible. We also have online training options that are obviously done, at your kitchen table or at your desk. So we do know that local community. We've been around. We've made great relationships over the years, and it truly is our goal to make your business successful. So real quick before I pass this over, I wanted to talk about our closed loop manufacturing concept that we've kind of been rolling out over the past year. It kind of encompasses all of our products, and it's taking a single part and file through the entire cycle of manufacturing from art to part. It's a unique, efficient, and actually real-world tested way to take all these products and apply them. So with that putter that you just saw, we reverse engineered it with Verisurf. We actually made some changes and then printed it in stainless with desktop metal. And then taking a look at what Robos does with, they print plastics and super polymers, like carbon-infused polymers. Sometimes you need some interesting fixturing, and that could be tying up your CNC machine. So we took carbon peak and made some fixturing to hold that unique shape of the putter when we wanted to finish it. it held on really well. It has a, pretty good tensile strength in that material. So then obviously we program this in Mastercam. We can do, our preliminary programming with Cam Assist. We bring it into Vericut for our simulation to make sure we know exactly how it's going to run on the machine. And before, during, and after probing was done with Mastercam probing, formerly Simco. Then once we were done, as you can see, these are real pictures. We definitely did this. We did our final inspection with Vericut to make everything was good, and we can go and hit the links with it. So one caveat there, this will not make you a better golfer. It did not make me a better golfer, but it is really cool. And I love it in my bag. So again, we do offer all these products. If you're interested in this concept, it's pretty unique. You head over to machinedesign.com, and I added this in this morning so you could see it. You just go on the top right, click search, and just type in putter, and then there's a 4-part series. These are kind of out of order based on how the search came up, but you can read through those and go through our process. Now I'm going to stop sharing my screen, and I'm going to pass it over to Jake.
Okay, and away we go. Let's see. All right, you can see it.
Yes.
Okay. So let me hit reset here. Okay, so thank you, Graham. I'm excited to be here. Excited to work with CAD-CAM Consulting. I've worked with Frank for quite a while. This is an exciting, day for us. This is an exciting product that we're now offering, and so we're excited to get the word out there. I'm going to go through and explain kind of who Vericut is and kind of explain this product and see if it makes sense for you guys. So who is Vericut? Vericut, we were established in 1988. So our home office, our headquarters is in Irvine, California. So right down there in Orange County. A lot of you guys are familiar with that area or familiar, where that's at. We have about 220 employees. We have 12 offices around the country. So we're a worldwide company. I'm not going to go through each one of these, but that's just to kind of illustrate that, we are growing and we continue to grow every single year. That bottom right hand section there where it says partner with CNC software for 20 plus years. We also work with all the different CAD-CAM systems, and we're happy to work with those guys. We're happy to work with, the CAD-CAM softwares. We need those guys to work with us. And so we're excited whenever we get to work with somebody or partner with somebody. We always appreciate those relationships. Jumping into the products of what we offer. So this far left-hand side where it says Vericut Optimizer, that's what we're going to be talking about today. And I'll walk you through what that looks like and how that would fit into your guys's process flow. The next one is Vericut. So Vericut is the core of who we are. So that's who we are. We are Vericut. This was our first product that we made, and it continues to be a strong point for us. We are all about simulating CNC machines, and a lot of that happens inside of Vericut. The next product that you maybe have not heard of or not familiar with is VDAF, so Vericut Drilling and Fastening. So imagine, some of these robots that are drilling holes and then they're replacing fasteners inside of those holes, things like rivets for, airplane wings and things like that. The next one we have is our Vericut Composites applications. So these are growing as well. We have our VCP, so our Vericut Composites programming side of things, and we have our Vericut Composites simulation. So this side would be more like your post processor and you're programming these composite machines. And then this side is kind of like Vericut in that we're simulating all of that code that you're feeding into the machine to make sure that everything simulates and verifies correctly before taking it to that machine. The last product that we offer is our post-processing. You can see down here at the bottom, this says that it's powered by iCam. So we acquired iCam. So now our Vericut Post, we're able to post using that iCam software. And so if you guys are interested in that, that's another option that we have where we have a lot of cool technologies where we can post using that software. Okay, so Vericut Optimizer. This is This is what we're here for. So it's a standalone application. Um, it's meant just for optimizing, so it's meant to be an ease of use software. It's for everybody, so any sort of CAD-CAM system, as long as you're running G code, we can optimize it. It's meant to be an affordable option for you, right? That kind of goes back to that no Vericut needed. You don't need to buy a full seat of Vericut. You can just buy Optimizer and optimize your programs. And the last part that I'm going to talk about at the end of this presentation is this rapid payback. It's not too often that we come across products where there's a real measurable difference where you can measure how fast a product's going to pay for itself. And this is one of those products where you'll be able to see how quickly it pays itself off. Um, Not going to read through all these different bullet points, but the main thing here I wanted to show you guys is that you guys can optimize apt code like CL data for Mastercam. It would be your NCI code, or you can optimize G code. So any of your G code that you're getting out of Mastercam, you can take that into Vericut Optimizer and optimize it. It doesn't have to be new programs, and it doesn't have to be old programs. If you've got a program that's on the shop floor that's been running for years and you're looking to get some more performance out of it, this is a great product for you. If you're looking to optimize your programs right out of the gate before you even take them to the machine, you can do that too. So we're accepting of all G code, new and old. It doesn't matter. We can still optimize it. Down here at the bottom it says we've got detailed tool use and graph windows. I'm going to show you what that looks like inside of Vericut Optimizer. So why is optimization needed? This is a great conversation. One of the coolest things about my job is that I get to help teach people. I get to help teach people concepts or teach people things that they may not be aware of. This is one of the neatest and the coolest things inside of Vericut and Vericut Optimizer is these graphs windows. As we're cutting inside of Vericut and Vericut Optimizer, we're able to take measurements all along the way and see and give you that data back. And so this is really a good tool for you to get feedback on how your programs are doing and where you're at in your programs. So think about this part right here. So I've got this aerospace bracket up here on this part of my screen, and you can see that this end mill, this is looking from the top down view. We're going to go around this part and we're going to finish this part, or maybe we're roughing, doesn't really matter. We'll see a thinned chip thickness up here on the straightaway, and as we go on the outside edge. And then what do? We bury that tool in this first corner and we bury it in that second corner. There's not a real good way to kind of fix this, right? We kind of have to finish that part, or that's how we finish our part, or that's how we rough out a part. As we bury that end mill into those corners, we see things like this, where we see this big load up on chip thickness. So what that's doing is that's beating up our tool. We might be seeing chatter. We might break a tool. We're stressing out that tool inside those inside corners. So what do we end up doing? We end up picking a feed rate that satisfies kind of that worst case scenario. So we take the feed rate and we bump it down, and we're like, okay, well, it made it through those two different corners, and that's our feed rate that we chose. So Vericut Optimizer, you can see down here, I've got these dollar signs, right? We can, if we could push that chip thickness up to like that 4,000th chip load throughout the whole entire program, wouldn't that be great? Wouldn't we be able to get a faster program? That's exactly what Optimizer is doing. And I'm going to show you guys exactly what that looks like and how it works. Okay, so I'm going to go ahead and just kick off this Optimizer right here, and you'll see these graphs populating. So some of the key points with Optimizer and with, I guess, machining in general, we want to make sure that our tools are cutting at the top end, right? If a tool manufacturer tells me that an end mill cuts between, they want a chip thickness of between like 3 and 5 thousandths, I want to be running in that range as often as possible. That's going to do two things for me. That's going to give me the best tool life possible when it's in that range. And it's also going to give me the fastest program possible. So those are the two kind of main points that I want you guys to think about is chip thickness gives me better tool performance for the life of the tool, and it also gives me a faster program, which I want. I want to get this part off of my machine as fast as possible so that I can make more of them or I can get on to the next job. We're all here to do the same thing. We're all here to make money in those machine shops, and we do that by doing it as efficiently as possible. And that's why optimization is needed. We can reduce cycle times by 5 to 35%. Actually have seen more depending on the CAD-CAM system. If we have really inefficient programs to begin with, we can squeeze even more juice out of these programs. Like I said, we can prevent tool breakage. We can also limit excess tool wear on our machines. We do that through maximizing a constant chip thickness. The third kind of big point that I like to talk about with Optimizer is that we get to make safer programs as well. So I'm going to demo this for you guys and show you how we can kind of get this third benefit out of Optimizer. We can limit the amount of excess tool deflection, forces, horsepower that we're seeing on our tools and on our machines. And I'll show you guys exactly what that looks like. Okay, so just to run through this real quick, this is kind of a different way of thinking about your program, seeing it on a graph versus taking it out to the machine and listening to it or seeing it ran. This is what we typically see in our programs. I've got a feed rate of 25 inches per minute, and it's a constant feed rate throughout the program, or at least it's constant through the cutting portions of my program. And then I see my chip thickness varies depending on the conditions that my part is seeing or that my tool is seeing. What Optimizer is going to do is it's basically going to flip these two graphs. So if I go to the next slide here, you'll see that Optimizer is going to change your feed rate. You can see that this is in inches per minute. We're gonna alter your feed rate throughout your program in order to get a more constant chip thickness. This is the ideal. Remember, this is what the tool manufacturers told you about, right? They said, okay, run this tool at this surface speed, and then I want you to run it in this chip thickness. So we kind of do it backwards in our CAM systems. We start with this number and then we calculate, a feed per minute, and then we keep it constant like this. But it's not the truth. Our tool is engaging that material in different ways, and so we see different conditions throughout that program. So this is the goal, and this is what Vericut Optimizer is going to do for you in your program. Okay, so I'm going to go ahead and just leave that up. So I've already optimized this program. I'm going to jump into Optimizer and kind of show you kind of the same thing again, just to reiterate the point. So I'm going to zoom in on this portion of the graph. And temporarily, I'm just going to turn off the optimized portion. So as I was running this part, as I was cutting it, this is what the condition was, is what I saw. So I saw that the chip thickness is varying, and I've got a constant feed rate. Right, I can slide this over here. So a constant feed rate of 29 inches per minute right here with this particular tool. Turn on the optimize and turn off the original just for a second. It's not a perfect flat line, but it's very close. You can see as I drag this little red ball around, you can see that down here, my inches per minute, my feed rate is varying, but my chip thickness is more constant. And this is what I'm after right here. If I show you both programs, top and bottom, are overlaid on each other. This green section here is a gain. So this is where I've been able to push my program up higher. If you see a section right here that's red, that's where it was pushed down. And so the green in between is gains. That's where we were able to go faster, right? I was able to go faster. I was able to get that program off the part, or that part off of the machine faster by maintaining a more constant chip load, and then also getting better tool life by keeping that tool where it's supposed to be. If I run down here too much, I'm gonna rub that tool too much, and I'm gonna wear out my tool prematurely. If I run it too high, I might break that tool. I might stress that tool out. I might put too much heat into the tool and end up chipping it, breaking it, wearing it out. So that's how we do it. That's the whole secret sauce between Optimizer, is that we are all about chip thickness. So that's something to keep in mind when you're programming your parts or when you're considering buying Optimizer. But there's more. So remember there's the kind of that third leg that I was talking about where we can also make safer programs. So looking at this same section here, I'm going to show you a little bit more. So if I turn on, let's turn on power just for a second. So you can see that the power, this is in horsepower for my machine. So think about this like spindle load on your machine. Um, as I'm running throughout this part, I'm seeing some spikes in horsepower. So let's talk about the third leg here of how I can make a safer program. I can also set up limits inside of Vericut Optimizer that Optimizer will abide by, and it won't go over these limits. So if I go into Tool Manager, so Tool Manager is where you change all of your different settings. Frank is going to take you through how to get these tools out of Mastercam into Vericut Optimizer. It's a very easy process. We have an interface that does that. I can go in here and I can say, okay, maybe I've only got 10 horsepower on this machine, or maybe I've only got 8 horsepower. I don't want to stall the spindle out. I don't want to really beat up my spindle or push it too hard. So I'm going to set a limit at 7.5 horsepower. So you can see right here, this is 6, that's 8. Maybe I want to limit some of these spikes that I'm seeing in my program as well. So I'm going to go ahead, turn that on to limit, and set that to 7.5. Save that. And I'm just going to re-optimize this program real quick. And there's more. So inside of those visible graphs, there's deflection, there's power, there's torque, there's machine force. You can split out the forces between radial and axial forces as well as total force. So there's lots of different options. You don't have to use all of them. All of these things are optional. Remember, our main thing that we're after is chip thickness. We're always driving after chip thickness. If I turn on my limits right here, you can see where I've set these limits. Vericut is always going to try to push up to that limit, but it doesn't want to go over that limit. So we don't want to go over the chip thickness value that I've set. And same thing with the horsepower. So if I zoom in on the same section that we were looking at, you can see that I've got this limit right here. And what did Vericut do? It actually, if I zoom in right there, you'll see it. It actually went down, actually cut my feed rate down in this section, which also drove my chip thickness down temporarily. But what it did is it made a safer program in that now I'm not pulling so much spindle load when I'm cutting in this section of the program. If I back out and zoom out, I was still able to see lots of different, grain in here where I was making some gains. If I turn on my optimization calculator, you can see that I was still able to save 35% cycle time on my program, even though I had this small section here where I cut it down. So that's the kind of third thing that we offer, is that's how we get to that safer program. Okay. So these graphs, I have to be careful when I talk about them. I think because when I discovered these, like when I first started looking at these graphs, I thought that this was really cool. I still think it's really cool. It's something where nobody has shown you your programs like this before. You can run them on the machine. You can simulate them in Mastercam. You can simulate them in NX, CATIA, whatever. But nobody is showing you these graphs like this or showing you this data. It's kind of looking at your programs under the microscope. And still today, what's really amazing to me is that while we were doing that, while Vericut was running around cutting this part, it was measuring and it was writing out a new optimized program. So let me go forward here. So I talked about this, limiting the forces, the power, the tool, the deflection. Well, and that's another thing too. Let me show that real quick since I talked about it. So maybe if horsepower is a harder thing for you to visualize, maybe you look at it more like deflection, right? So if I turn on the same graph in this kind of same area, you can see that about, almost 2/1000ths of deflection at the tooltip is what I was seeing in this particular region here. I could go back into Tool Manager, and I don't have to use horsepower. I could ignore that, and I could turn on deflection and use this limit that I've set up here, and I could limit it to where Vericut's not going to go over that, 1/1000th, 8/10ths deflection at the tooltip itself. So lots of options. Like I said, we teach an entire class on how to do this and how to go through all these different settings. Very intuitive, very easy to use. Okay. The other thing that I wanted to show real quick was once you're done optimizing, Vericut goes out and it writes out a new program for you. So on the left-hand side is my original program. On the right-hand side is my new program. So you guys you'll pick up on this really quickly and see what's going on here. So you'll see all these different F values. So feed rate of 57, 58, 59, 60, 56, 54. That's all we're doing. We're not adding extra cuts. We're not adding in lead in and lead outs. We're not changing the trajectory of your toolpath in any way. We have the ability to cut it up into smaller segments and then apply different feed rates. And we're applying the correct feed rate for the chip thickness that you've told us about. Okay, so what does this look like for you guys, or how would this change your guys' workflow if you guys were to, to use this today in your guys' machine shop? Step one, we're gonna get all of our information out of Mastercam or whatever CAD-CAM system you're using. We've already defined these tools in Mastercam. We've already defined our stock and our fixture inside of Mastercam. So we're not going to redo that work. We're just going to take everything and we're going to steal everything from Mastercam and we're going to take that over into Vericut Optimizer. Once we've done that, we need to tell Vericut what material we're using. So if I go back into Tool Manager, in order for Vericut Optimizer to correctly calculate the force, the power, and the deflection, you need to let Vericut know what material you're cutting. If this was something like wood, you can imagine the horsepower or the deflection would be much less than something like titanium. So you'll tell Vericut what material you're cutting, and then after that, you'll click on that optimize icon. So just to run through it real quick. So I'm going to show you guys what we call the project tree. I get all of my information from Mastercam. I get my tools from Mastercam, my fixture and my stock from Mastercam. I'm going to post my program just like I normally do. I post it out of Mastercam and then let Vericut Optimizer know where that program is at. The next thing I need to do is let Vericut know what material I have. So in here, we've got a big long list of materials that you can choose from. I prefer clicking on this icon here. So in here, I can sort these materials by their different groups. So I could go to, something like, my aluminums and pick which aluminum it is, or if it was a titanium alloy or something like that, I could go pick my material. Once I've let Vericut Optimizer know what material I've selected, from there, I'm going to click on the optimize icon and I'm going to start optimizing my program. Any sort of changes that I need to make, I can go back into Tool Manager and change those different settings like I showed you guys how to do. So maybe I want to push this chip thickness up more. I've seen this a lot with users where they'll optimize the program here and they'll say, hey, that ran pretty good. We're able to, get a lot more performance out of the tool and out of the machine. Let's push it up. Let's push it up a little bit more, right? So I could go here and I could go back into Tool Manager. And I could say, hey, it ran really great at that 3.8 value. Let's start pushing that up. Let's push it up to a 4.2. Save my TLS file, re-optimize it, and now I keep getting that cycle time further and further, or start driving that cycle time further and further downward, and getting more performance out of my tool and out of my machine. So as simple as that, 3 steps. The last thing I wanted to mention to you guys is this return on investment. Like I said, kind of at the beginning, it's not too often where we come across these tools where you can very quickly see how much it's worth, and you can see how fast it can pay itself off. I've got a customer that I've worked with quite a bit that cuts a lot of titanium, and one thing that he mentioned to me was like, I can't believe more people aren't doing this because this thing pays itself off for me in a matter of like a month. It's already paid itself off. But he was cutting a lot of titanium. Um, so you can see my original time was 11 minutes and 30 seconds. And keep in mind, guys, that this is just a roughing end mill. This isn't the entire program. So if I have 11 minutes of cycle time, I was able to cut out 4 minutes. That ends up being about 35%. Um, if I cut 100 of these parts at $150 an hour, that ends up being, $1,000 saved, very quickly. Um, One thing that we, forget to mention too is that, that's almost 7 hours of free time that I get back, right? If this was on, a three-axis mill, now I've got 7 hours, I've got almost an entire shift back where I can go make other parts with this machine tool. So very quickly, this is a tool that can help you guys make better programs up front, safer programs as well. And it's something that can easily pay off itself. So pretty cool. I think it's really cool. I get really excited about our optimization software. So thank you very much. I'll pass the time back over to Graham or Frank, and Frank's going to show you guys the Mastercam to Vericut interface.
All right. Thanks a lot, Jake.
Yep.
Thank you, Jake. So let me go ahead and share my screen. Move this out of the way. Are you guys able to see my screen? All good? Perfect.
Yep.
Okay, guys. Well, yeah, so what I'm going to be showing is just like pretty much the workflow on how to integrate, right? Everything Jake just showed in Vericut, bring it across from Mastercam in this case. This can be done with any other CAD-CAM software. But the workflow here in Mastercam would be, the normal things you would do. Come to your stock or your job setup, and you're going to go ahead and define your master model, meaning what's going to be cut, your stock, right? So if I come to my levels, turn on my stock, or you can see it in red. This is what's going to be removed, right? And then the next thing we want to select is our work holding, our fixturing. In this case, I have everything. You can see it highlighted in yellow here in a level. And then along with that, your tool library. And this is a workflow that you guys should have already, right? But if you guys are using machine simulation or anything else, it's the same workflow. Go ahead and check mark to that. And then another thing that's going to be required to be able to import this into Vericut would be creating a plane. So we would need an attachment plane. So what that is just where do you want to place all our models, when we bring this over into Vericut. And if you could see here, I'm just my attachment plane's right at the bottom, middle of this nice picture. Perfect. Okay, so once we have that, that's pretty much all we need. And again, this is just the normal workflow that you're doing regardless, so nothing really different, right? And then we go into the Vericut interface, and in here I have it you could have it in multiple places. I created a tab here for this demo purpose, and I also have it on the quick access toolbar here, so either one would work. So once you go into the Mastercam interface button here, this is what pops up, right? So it wants to know your working directory, so where your project in this case is going to be built. All this information that we're transferring over to Vericut, this is where it's going. And then you want to give it a name. In this case, I'm going to label it Vericut demo. And then you also want to make sure that you select your project template, meaning what machine you're going to be using for this project, right? And then you just want to put all the operations into a single Vericut setup here in this case. And also, if you have multiple groups, toolpath groups, you could select all or select one only. In this case, we only have one, so all or select only would work. And then we go down to like this. The first tab here is a model. So you'll see that everything that we did on the job setup, from our stock, our model, and our fixturing is everything's being transferred over. If for whatever reason you need to change this, you still can. You have control. You're able to come here, select, and either clear it, add from a different level, or go back into the Mastercam drawing area and select it. And it's the same thing with with your design or your model, and then also with the fixturing. The next thing you're going to do here is go ahead and select your attach plane. In this case, we label it, our Vericut attach. So you go in here and select your plane. After that's done, we go over onto the next tab, which is for your tools. And as Jake mentioned, I mean, we've already done all the hard work, right? We already defined everything in Mastercam. So what I'm going to be using is just generate my tools from Mastercam. So that's going to bring all my tools into Vericut. You can also use it from your template. So if you already have all your tools in the template in Vericut, then you can just use them from there or merge them from elsewhere or select them from an actual library. After that, we go ahead and select our program. In this case, you can use the NCI for Mastercam or the G code. In this case, I'm going into my directory where I'm posting and selecting that G code. And then the next thing over would be your work offset. This automatically gets populated. This is just meaning, how you're using your work offset, whether you're using G54, 55, etc., or 1, 2, 3. So that's where it will start. And the next thing over is just it's a setup template. So this meaning if this work or after you're done running this part, is it going to be the leftover stock? Is it being ran on another machine or another project? This is what you would do it. What else here? Another cool thing here is that you could save your settings. Saving your settings will save all the information you just brought over, so you don't have to redo it. When you do hit that save settings, you would see in your Mastercam levels that it'll create a level called CGTech, pretty much saving that in the background. So after we're done with this, we can go ahead and just hit output and run. So this is gonna output, like, get all the information we just got, and then open up Vericut to run this. This is being live, so hopefully it doesn't delay or slow. And you'll see that it opens up and everything's been imported directly from Mastercam with our fixturing, our stock. You can see here we have multiple views. We have our machine view or our workpiece view. You are able to come in here and turn off certain components on the machine if need be under component visibility. So you can turn off your enclosure, inner enclosure, depending on what you want to see. Go ahead and see that. And then we can see here, we have our program. I'll reset this and I'll go ahead and just hit play. So you can see the true G code being ran on the machine. If you guys have any questions, please don't, go ahead and type them on the chat while we see the simulation. We can go ahead and speed this up or slow it down as need be. Any questions?
One thing that's worth noting, Frank, is that Heidenhain, Siemens, Fanuc, Fadal, like whatever G code you guys can throw at us, we can simulate it. So as long as it runs on a CNC machine, we're able to simulate it. File extensions don't matter with the interface either. So if it's an MPF or .NC or no file extension at all, there's no problems simulating that kind of stuff inside of Vericut.
Sure.
And like you said, like we're reading the real G code, right? There's no games here. We don't have wireframe geometry or anything like that. We're reading the actual G code.
Correct. Yeah, and that's pretty much it, guys. I mean, it's a simple plug and play. Again, you're not doing anything that much different than what you're already doing inside of Mastercam if you're doing it right. Going from the job setup, other than just the attached plane, give it a little bit of information, and then you're ready to verify it, make sure everything's going to be good on the machine, right? No crashes, no nothing. So, questions? Go ahead and stop sharing my screen. There's anything you would like to add, Jake or Graham?
No,
No,
I thought
no.
that was excellent.
So I guess just to point out that Frank showed you guys the Mastercam to Vericut interface. We use the same interface for Vericut Optimizer. It's just a little bit more simplified, but it's the same interface. Um, yeah, and the idea there is just to make it easy. No need to do the work again. Just grab all the information out of Mastercam and then push it over into Vericut Optimizer or Vericut. So
Perfect. As I'm sharing my screen here, one thing that really stands out to me is full disclosure, I'm not a CNC machinist. I'm the marketer. I stayed at a Holiday Inn Express last night. Been around the industry for about 20 years. I can fool around in Mastercam. I can certainly talk about it. Same with Vericut, but you guys definitely made it seem a little more daunting than my time in these pieces of software, or less daunting, sorry. So well done. Can everyone see my screen?
Yeah.
yep.
Perfect. Okay, I'm gonna wrap it up. So just quickly, Vericut Enforce. It's going to give you a faster turnaround, less outsourcing, predictable cycle times. You're going to avoid tool breakage and extend your tool life. On the optimizer side, it's a standalone product. You don't need Vericut verification. Certainly affordable. Optimizing feed rates and maximizing your chip thickness, as was shown. And then, Verica, it's simulation, right? It's reducing your errors and your crashes before they happen on the machine. It's improving your efficiency. It's saving you money. The ROI example Jake gave was perfect with his customer with titanium. Nearly any CAM system, we'd certainly appreciate it if you were a Mastercam user, but if you're not, you can, we're obviously still going to talk to you. And then the reductions in machining time are there. You can see them through what was shown. So then you bring in Mastercam, and it's a relatively simple process. You're generating your code in Mastercam. It's your familiar interface. There's such a tight integration between these two products that it really benefits the user. So next you're taking what you have in Mastercam, all that code, all the supporting information, you're bringing it into Vericut, and you're running it, and you're making any adjustments that you need to make. As Jake said, before you're going out there and listening or watching it cut, if you're a seasoned machinist, you can hear what's going on in the shop floor, even if you're not out there. This one's good too. So these are both Sandvik owned entities, these products. And they're backed by a huge corporation. And bringing those two into the fold allows them to have closer collaboration. Not that there wasn't a close collaboration before, but I'm really excited to see these two products, under the same umbrella and what the future really holds for them. And these two products as standalone, it allows them to focus on their core competencies. In my time at Mastercam Corporate, we always say, we're a CAM company. We're here to help you cut your parts. We leverage and rely on relationships and partnerships like this. Vericut is the best at what they do. Mastercam is the best at what they do. So utilizing that and putting it in your toolbox is just going to make you the best at what you do. So to wrap it up, where you can find us, CAD-CAM.com. I encourage you to sign up for our newsletter in the footer. You can find Vericut at vericut.com. If you have any questions and you're not typing them into the chat, you can reach out to marketing at CAD-CAM.com. We can hook you up with a demo, whether that's in person or virtual. We do have a Vericut page on our website. You can fill that form out. You can find both companies on social media. And as mentioned earlier, this recording will be on our YouTube page within a few days. It's going to be docked in our new playlist called CAD-CAM TV. If you follow us, you've probably seen this. It's a new playlist where we're really just taking our experts in the building and giving you free tips and tricks on the products that we represent. So, short form videos on just something that's going to help you be more productive at what you do with any product. And these are coming out weekly. There is our contact information again. And I'm going to pop the chat open and we will start doing that. Okay, so first question. Does it work on mill-turn or multitasking machines? And you answered yes, it does work with mill-turn.
Yep.
And so another yes answer, will it optimize live tool dual spindle lathes? We do have a question about cost, and we're not going to talk cost in this webinar. We are technical and marketing people for one, but also it requires an evaluation of your machines, what you need to do in your shop. So we really need to come out and see what you're doing. There's no blanket answer for that.
But I'd like to, I'm not sure if we mentioned, but it works the same, the Mastercam into the Optimizer only, or Mastercam into the Vericut with the interface. So same process.
Yeah. Give it a few more minutes and we can probably get you guys out of here a few minutes early. All right, last call for questions here. Here's a thanks. Thank you. Thank you for attending.
Thanks.
Thank you, guys.
Okay, I hope everyone has a wonderful rest of your day. Thank you for joining us, and we will be following up over the next couple days. And special thanks to Jake and Frank too.